So in this segment, we're going to look at the Centipede code. So for the code for the Centipede base class, Centipede head, and the Centipede node. Um, we'll see if we can't get to the distance calculator in the instructions this time too. Centipede node and the instructions should go together. Okay, so here we have the Centipede base class. The Centipede node and the Centipede head are both derived from this class. Here we have the .h and the .cpp. So in the base class, we have make head, which is called by a body part when it's destroyed, the body part in front of the body part that this is called on. And basically what this does is this makes that body part the new head. So it calls new head on it, or it creates a new head with the position, the next body part after the body part that's being called on, and with the body part's position and its direction. And then it deactivates the body part. You're going to see a few of these active things. I'll explain when I get to the code in the Centipede head. But there's something weird with timing and labeling of pointers that are being destroyed. Anyway, so here we have the function set next, set previous, which next is the Centipede node further down, so we're able to take in a Centipede node. And then set previous is Centipede because it could be Centipede head or Centipede or a Centipede node. So we just take Centipede in, return position, move sideways. Okay, so this is where we calculate move sideways. Thinking about it, I could have done this in a strategy pattern, but I ran out of time at the end. So this function, move sideways, obviously moves the player sideways. And the tests are done elsewhere, so there's not a lot of tests in this. This is just add the position or add the movement amount. Multiply it by direction. Direction is either 1 or -1. So -1 would obviously be going left, and 1 is going right. We're not moving on the y, so the y is 0. Distance is used to calculate how far we still have to go until we go to the next instruction or check the whether or not we need to turn again. Or not whether or not we need to turn, but check for the turning. This is clamping, so this is an attempt to try and control the gaps in the Centipede. I'm not. It works. It helps. It helps, but it doesn't fix everything. This is my move vertical function. So when I'm moving vertical, go down. First we check if we're at the bottom of the screen, and if we are, we flip the vertical direction. If we're not at the bottom of the screen, and if our position is lower than the player area, then we also flip the vertical direction. So we do the same thing we do in the move sideways, subtract distance, and do some clamping. This helps for keeping the Centipede aligned with the mushrooms, and so it actually drops only 16. Otherwise, sometimes it drops just a little bit more, and after 30 so rows of doing that, it can get a little askew. This is for initializing the sprite and other collider type things. This is called in the Centipede head and Centipede node constructors. What it takes in here is it takes in the name of the sprite. That way we can use whatever sprite there is for the node or head, and we only have to have one function that initiates all this. Okay, sorry, my headset keeps doing that. It's a Logitech headset that just has that pre-installed where it cuts out. So yeah, so we return movement amount here. It's the draw function. If it's active, then we check for the direction, and if the direction is one way, then we go one way. Otherwise, yeah. Well, if it's going right, then we set this. Subtracting from the animation, Centipede sprite, destruction. This only gets called at the very end, or a reset of the wave. I'll get to that in a second. That's why I wish I'd been ahead, thought ahead and done these in a factory, but I didn't. I did kind of a pseudo-esque doing what a factory would do, but not really well. So we have deactivate here. This sets the previous next to 0, sets the next previous to 0. It sets active equal to false, puts the position off screen, deregisters collision. Yeah. Destroy all. This is called in the AI spawner for a reset of all the AI. It destroys all of the head and body parts. So it's called on the heads, and it goes down the body part list and destroys it. And destroys the body part. This is collision. We only have collision for a bullet. So if here we see the make head part. So this is called on the next body part down. If there is a next body part down, then sets that to 0 for it. This head, if it's a head, then we subtract head from the game manager count, which helps us keep track of the wave. Subtract head from the AI spawner. This actually, well, we'll look at this later. This is where we keep track of the heads for the destruction. So score, we add the score of a centipede head if it's the head. If it's not a head, so else, we add the score for a regular centipede body part, which is only 10, head's 100. Call spawn shroom at the position from the mushroom field. We reset the bullet, and we deactivate this. So now let's look at the centipede head. So the centipede head programming. Here we have two constructors. So if you noticed in regular centipede, I'll go up to the make head function. This constructor takes in speed, a pointer, the position, and direction, while the base constructor only takes in how many nodes and the speed. So, and then it constructs the rest of the nodes here with a recursive function that gives centipede node the number of nodes, speed, and a pointer to the head. So here we have the other specialized constructor, which is called in the new head make head function. Takes in a pointer to the next node, the position of the original, direction of the original, speed of the original, adds head to game manager. If there is a pointer, then it clears the instructions for the next node, which is also a recursive function that clears the instructions for all the rest of the nodes. Sets previous equal to 0, head to true, yada yada. Now it repositions, it calculates its position based off of the mushroom grid. It goes to the nearest grid that it was just at. And then it repositions all the rest of the nodes to that position, or to an according position behind that head. here we have the update function. This checks whether or not there needs to be a recheck of the row that it is in for mushrooms, if a new mushroom is spawned there or destroyed. Calculate the movement amount. If the distance is set to 5,000, that's the initial distance when a new head is constructed. If it's set to 5,000, then we get a new initial distance, which can really only be put here, because if it's not here, weird things happen when it's put in the constructor. Weird things happen with the nodes. So now, if distance is less than or equal to 0, so it doesn't have any further to go, and it's not already turning, so it's not going down, then it initiates a turn, and it checks the mushroom field. It asks it to check if that mushroom is poisoned, and if the mushroom is poisoned, distance equals 320, it's an arbitrary amount that will get it all the way down to the player area. And the check vertical will catch that when it gets to the player area. Otherwise, the distance is 16 pixels, or 16 distance. I don't know if it calculates pixels, or I'm pretty sure it does. So now, if the next is available, then it adds this instruction to the next player, or the next node. The weird thing that I was talking about and why I need the actives, and I discovered this really late. I had a glitch where this, even though it's always set to 0 when the node is being destroyed or a head is being destroyed, it always sets the next and the previous to 0. It would get through this. For some reason, it would get through this, and then it would call this, and my game would crash. So I had to do this right here, and if you see any of these, this next, that is because of this crash. That's why I have the active check. So yeah, initial distance is now this distance. That's for the clamping. So if we're not turning, then we move sideways. We call the move sideways function. If the distance is less than or equal to 0, so since we've already passed this and we're on another else if, so at this point we are turning, or we were turning, we call this. Then if we are turning, it's the last thing, move vertically, set position. So here is where where is it? Oh, yeah, sorry, I completely glossed right over this. This is the getDist function, which we will be looking at right now. So if the distance is equal to 0 and we were turning, we calculate a new distance. So we first set distance equal to the closest shroom, which closest shroom returns the amount of cells that we have to travel sideways. Then, and this is just, these values are just a way of calculating the cell position. And then we call distance equals distances getDist, which that is actually the one that returns the actual values of distance. It has an array of all the distances that could possibly be in the game, like as far as possible. From 16 to, I think it's 480 divided by 16. So we'll look at that in a second. And then if this has a next add instruction. It's the distance and direction. Init distance equals distance again. This is a function that checks if the it checks the closest shroom. So this is called when we need to recheck the row. So this returns false if the distance has not changed. It returns true if the distance has been altered. And then this is the initial distance. Yeah. We have to minus a y to calculate for the HUD top here. Centipede node. I'm not sure how long this video is becoming, but actually this seems like a pretty clear stopping point. I'll stop, and then in the next segment I will talk about the Centipede node and the distance calculator and the instructions.